All right, this week we're talking about representing proportional relationships. And sometimes we can make ourselves a table, or we can graph these things. And I'll show you how to graph them in just a second. The function table below shows the relationship between the side lengths of a regular octagon and its perimeter. If a regular octagon has side lengths of 8 inches, what is the perimeter? And so basically what we've got here is the if the side length is 1 inch, well then of course we're going to have 8 inches as a perimeter. And remember, a perimeter is, if I have for example, if I got a little cup holder here, the perimeter of that is this the outside edge. If we have a square, the perimeter is all the sides added up. For example, 1, 2, 3, and 4. An octagon is 8 sides, and how you can remember that is octagon is like an octopus. Octo means 8. Well, in this case, we're saying if the length of the sides are 1 inch, then we're going to have a perimeter of 8. If the length of the sides are 2 inches, we've got a perimeter of 16, and 3 is 24, and so on. You can start to see a pattern here. This is what we call a linear relationship. And basically what you're seeing here is a pattern. For the length number of sides, the number of for the length of each side, you're going to basically multiply it by 8 because there are 8 sides. Okay. So what it's saying is, well, we know what 1 is, we know what 2 is, we know what 3 is, and basically what we're saying is the number of the side times 8 will equal the perimeter. Okay, and we know that here because we can plug this 1 in here. 8 times 1 equals 8, and we can see that here. Well, now that we have an equation here, 8s equals p, we can figure out what 9 is, or we can figure out any number of the length of the sides. So all we need to do is plug that in and multiply that by 8. So we would say 8 times 9 equals 72. And like I said, we can figure that for any given different numbers. An empty swimming pool is being filled at a rate of 8 gallons per minute. Make a graph to display the amount of water in the pool after 8 minutes. Use the graph in the table below to help you. Up here we can simply put the input, which would be minutes, and the output, which would be gallons of water. And we'll have 1 minute and 2 minutes and 3 minutes and 4 minutes here. What it says here, an empty swimming pool is being filled at a rate of 8 gallons per minute. So in 1 minute, and a lot of times you should probably start with 0. And of course in 0 minutes you would have 0 gallons. I know it sounds silly, but you might want to start with that. Then of course we would have 8 here, and then we would have 16 here, we would have 24 here, and we would have 32 here. Because all we do is simply multiply the number of minutes by 8 gallons. And then of course we could plot it on a graph here. What we have to remember though, the input, which will always be x, goes along here. This would be something that's constant, something that can't be manipulated. In 60 seconds from now will be a minute. That cannot be manipulated. That is something that's in nature, and we can't change it generally. That's what the x is. That's what we call the input. And the output is our result. You can think of the output as a result, which is y. And that's why in a coordinate you would have x, y, like so. And you learned that last year. Well, let's take a look at this. Let's label this. We've got 0 labeled already. Let's put our minutes here. We got 1, 2, 3, 4, 5. And why don't we just do multiples of 8 because it's simpler. 8, 16, 24, 32, and 40. Well, for every 1 minute we get 8 gallons. For every 2 minutes we get 16, 3 is 24, and so on. Now, this is what we call a linear relationship, which means that there is a pattern there, and forever and ever, amen, that line will go straight like that. So we can plot it. We can go out here for 5,000 minutes and figure out how many gallons will have been put in that pool, and so on and so forth. And you can do this with any linear relationship. Sometimes some relationships are not linear. They're called exponential or whatever what it might have, and where maybe after the first few minutes you start getting more gallons per minute. and more gallons after that. And we'll talk more about that later. You'll learn a lot more about that in 8th grade. But right now we're dealing with linear relationships. And you can graph any of these at all. Okay. The graph below shows the amounts charged for purchasing different numbers of roses from a florist. Is there a proportional relationship or a linear relationship between the number of roses and the cost? If so, what is the constant of proportionality, and what does it mean in this context? Basically, what we're asking here is the price of roses constant? Let me give you an example of this. Let me give you an example of what is not linear. If I buy a 6-pack of soda, they're about $2. Okay, well, I can buy a 6-pack or 12-pack of soda for about $3. And basically what that means is the more I purchase, the cheaper they are per unit, the cheaper they are per soda. That is not an example of a linear relationship. Now, an example of a linear relationship is, for example, if you go buy a soda at a soda machine, here at school, for example, 1 soda is $1, 2 sodas is $2, 3 sodas is $3, and forever and ever and ever, amen, that relationship will be linear. It will increase $1 as you buy more sodas. If sodas were $2, it would be 1 soda is $2, 2 sodas is $4, 3 sodas is $6. And even though you're not going up by an increment of 1 every time, it is linear in that it is increasing by the same amount every time, and it will forever and ever and ever and ever, amen. That is not an example of what I spoke about earlier with the 6-pack, then going to the 12-pack. Then if you go on and buy a 24-pack, you can get them for, somewhere around, $5.50. I'm just throwing out numbers here. So what I'm saying is the more you buy, I'm sure if you went down to Coca-Cola and you wanted to buy 5,000 sodas, that would be much cheaper per unit. And that, again, does not represent what we call a proportional or a linear relationship. And the way you can tell, always, linear, the word linear means line, or comes from line. And what that means is a straight line. And we do have a straight line here. An example, 1 rose is $2. 2 roses is $4. 3 roses is $6, and so on and so forth. In other words, the dealer didn't come to you and say, look, the more roses you buy, the cheaper they are per rose. No, that's not the case. In this case, if you buy 1 rose, it's $2. If you buy 2,000 roses, it's going to be 4,000 because you're multiplying the number you have by simply $2. And then you get the output of $4,000. Okay? So, what is the constant of proportionality? Basically, is 2. For every rose you get 2. And I know that sounds a little complicated, but if you see this on a multiple choice test, you should be able to figure it out. Basically, what I'll ask you is this relationship linear? And basically, what is happening as the input goes up by 1, which is X, which is the number of roses, what is happening to the output Y? You need to know that X is what we call an input and Y is what we call an output. Okay? Here is my example. I buy 1 rose equals $2. Input, which is X, output, which is Y. Okay? Input, output. A movie theater charges $7 for a movie ticket. How much would it cost for 5 people? Now you can simply multiply that out and say, well, 7 times the number of tickets equals my cost, for example. So here I would say 7 times 5 equals $35. Okay? Write an equation to represent the situation. Well, I just did that right here. $7 times the number of tickets equals my total cost. Okay? Now, what they're asking you to do, and you're going to have to do this too, even though this may seem like a simple problem, make a graph to represent the situation. Let X represent the number of tickets, which is the input. Y represent the cost in dollars. Okay. Well, here, again, it has the chart here. We have, how much is 0 tickets? Of course, it's $0. How much is 1 ticket? $7. How much is 2 tickets? $14. How much is 3? $21. How much is 4? That will be 28. This will be 35. And this will be 42. You could simply plug any of these numbers into this equation to get your answer. Okay. Now it's asking us to graph it. Now, luckily for us, it's already got the x and y coordinates on here. All it's going to ask you to do is say, hey, look, we got to put the input here. The x will go here. Okay. So we've got 0 in the corner. 1, 2, 3, 4, and 5. And why don't we just make things easy and say 7, 14, 21, 28, 35, and forgive my writing, in 42. And all we have to do is simply plot this guy. Now, keep in mind, this is not drawn to scale. Okay? We will plot x, 2, y, 14, and so on. Now, I want you to also understand another thing. Make sure I got myself right here. 5, this is 6. Oop, I made a boo-boo somewhere. 1 equals 7, 2 equals 14, 3 equals 21, 4 equals 28, 5 equals 35, and 6. Yeah, I got it right. And what this line represents here, this line goes on forever and ever and ever, amen. That's what a line is. So you can find out any cost, and it can be represented by this. Or any number of tickets will be out here forever and ever and ever, amen. Okay? Now, I also want you to understand one thing. This looks like a line that's going, somewhat close toward the middle. A linear relationship or a proportional relationship can be any straight line. It doesn't have to be right on the dollar amounts. As long as that output is increasing by the same amount every time, that will work. But this particular one is this line right here. Okay? And you will be asked to graph those. Now, the table below shows the relationship between the side lengths of a regular pentagon. A pentagon is 5 sides. Write an equation to show the relationship between the length and the perimeter of the pentagon. All you have to do is say S for the side times 5, I know 5 and S look very similar, equals the perimeter. Now, normally I would say the number of sides times 5 equals the perimeter. Okay. Now I can do that, but remember we have to start writing algebraically. This is S times 5 equals P for perimeter. We can't say this anymore. We have to be big boys and girls and write it algebraically and say 5S equals P. And again, what this means is for any number of side lengths, whether it be 1 inches, 2 inches, 5 inches, whatever. I'm going to draw me a little makeshift. Is that right? 1, 2, 3, 4, 5. Yeah, this is a pentagon. So what we're saying here is if this side is 3, this side is 3, this side is 3, this side is 3, and this side is 3, we would simply multiply that by 1, 2, 3, 4, 5 to get the perimeter. Voila, we have that right here. We can also make an equation. 5 for the number of sides times times the side lengths, 1 inch, 2 inch, 5 feet, whatever, will equal the perimeter. Okay. You're also going to have to kind of think outside the box here and know your shapes. If a regular pentagon has side lengths of 8 inches, what is the perimeter? Well, you can either draw this out, draw yourself an octagon which has 8 sides. You can say, well, an octagon has 8 sides times the 8 inches here. That will equal 64 inches. I may ask you about a pentagon. I may ask you about a hexagon, which is a 6-sided shape, and so on. The graph shows the relationship between the cost and the number of uniforms ordered by a team. Write an equation that shows the relationship between the number of uniforms, X, and the cost, which is Y. And again, we have Y here and we have X here. Okay? You can very simply see 1 uniform equals $20. 2 uniforms equals 40. Again, a linear relationship because the line goes up. The dealer did not tell us, hey, you get a discount the more uniforms you buy. No. If you buy 5,000 uniforms, they're going to be $20 a piece. It does not matter how many you get. You can buy one, you can buy 5,000. This is a situation where buying in bulk does not get you a discount. All right, these are, again, $20 a piece. So it says, write an equation to represent or to show the relationship between the number of uniforms, X, and the cost, Y. Okay. So you can simply say the number of uniforms times 20 will equal the cost, which is Y. Okay. Is this right, though? No. You have to put 20x equals Y. $20 times the number of uniforms, X, equals Y, which is the cost. Now, if you plug any of these numbers into this equation right here, you will get the correct number. So what is the cost of a uniform? It's $20. How much will 6 uniforms cost? Well, you can do that one of two ways. If you have a graph here, you can simply look. 6 comes up to right here. Will cost $120. Or you can simply plug that 6 into this equation here. 20 times 6 equals 120. Okay. Amber rides 30 miles in 2 hours. Write an equation, and that should be that. That shows the relationship between the distance and the time that she rides. The distance and the time that she rides. So, for every 2 hours, she goes 30 miles. Can I figure out how long she goes in 1 mile? Can I do that? Remember that? Can I cross multiply and say, and solve for x here and get x equals 15? And what that means is for every hour she drives, she rides 15 miles. So can I say now, if we know that we're going 15 miles an hour, can I say 15 T equals D? My speed times the time equals the distance. Here we have someone who has 3 pounds of onions for $2.67. Write a ratio that is proportional to 3 pounds for $2.67. All we simply have to do here is say, look, we got 3 pounds of onions for $2.67. What is equal to this? Well, if I'm saying is it equal to this amount, what I would do is cross multiply like we learned back before Christmas break and solve for x. But this is asking us to come up with one that is equal to it. So all we need to do is simply multiply both sides by any number we want to. This will be 6. Let's multiply this by 2. 267 times 2, that's 4. Carry the 1, that's 13. Carry the 1, this is 5. 5, 34. And you can multiply by that by 10, you can multiply it by 20, anything you want to do. Number 12, a river rambler charges $20 a day to rent a kayak. How much will it cost to rent this kayak for 4 days? Well, if you need to, you can draw yourself a little chart here. Okay, you can say, and forgive my artwork, you can say 0 will cost you $0, 1 will cost you 20, 2 will cost you 40, 3 will cost you 60, and 4 will cost you 80. Or you can simply say 4 times 20. It's saying write an equation to solve this problem. 20 D equals the cost. Or 20 X for input equals Y for output, which will be the cost. Either one of those would be fine with me. Now make a graph to display this relationship. 0, 1 day, 2 days, 3 days, 4 days. This will be $20, $30, $40, $50, $60, $70, and $80. You can do that if you want. 1 will equal 20. 2 will equal 40. 3 will equal 60. And 4 will equal 80. Is this linear? You bet. That's a straight line.